So hi everyone, how you guys doing? First of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy. Every concept of physics, chemistry, and maths are being taught to you completely in English. And Unacademy already has become the India's largest online learning platform for IIT and this is another new channel that we have brought for you. This is to ensure that students who are not feeling very comfortable with the extensive usage of Hindi in the most of the content available on YouTube also now have an option to keep learning without language being a barrier. All right, so this is the series that I host for class 11 students. The topic that we are discussing right now is rigid body motion. This is lecture number 14. So this is the final lecture of rigid body motion series, and today we'll be talking about advanced PYQs. So we'll take a look at what kind of questions JEE advanced people like asking. Okay, and let's see if we can figure out how to approach such problems. So hello Rajesh, how are you? All right. So before we get started, let me introduce myself one more time for those of you who might still not know me. So my name is Rohit Dixit, and I studied mechanical engineering at IIT Delhi. And for almost past 8 years, I've been teaching physics for the IIT JEE Mains and advanced examinations. All this teaching so far had been offline. So offline, I had been associated with some of the topmost institutes that you may have heard of in the JEE coaching industry. Now, as a student, I myself was an All India rank 447 and All India rank 192 in the two stages of the IIT JEE exam that I took. Now, I also qualified at the NTC stage 2 and I was also in the top 1% in the NACP, which is the first stage of the physics Olympiad. Now, in all my offline career of teaching, I have coached many students to top ranks in the both IIT JEE mains and advanced examinations. So I've helped many students get to their dream colleges, get to their dream ranks. So now I wish to continue doing that here online with you guys. So how can you guys make sure that even in these kind of scenarios, even in this lockdown, you guys can keep studying and not only keep studying better than others and beat the competition in the JEE. So you can get yourselves the Unacademy subscription. Now, this subscription will give you benefits like live classes where you get to interact with your educators on a regular basis. So again, your classes go on smoothly. Your course preparation has absolutely no hindrance, no matter what. Okay, then of course you have live polls and leaderboards in these classrooms, which keep them highly interactive and very efficient and fun. Then you also have a test series and analysis session, so which will help you stay on your toes, which will help you be aware of your standing in the competition at all instance. Now, on top of all these, you have another great feature in all of the Unacademy Plus courses, which is you have live doubt clearing sessions. Okay, so these sessions will make sure that your doubts while preparation, while you're doing your preparations, never pile up. So I know, doubts is a huge part of one of the biggest problems that students face, right? Especially at this hour when your teacher's not easily accessible, so you don't know, if you have any doubts, where to go, who to ask from. So in Unacademy courses, that problem gets sorted because any doubt, after every three teaching classes, there is one fourth class is a live doubt clearing session where you can ask any doubt related to the theory, related to problem practice with your teachers. So we have a huge extensive discussion of doubts so as to make sure that there is absolutely no hindrance in your JEE prep. Next, on top of all these benefits, Unacademy is now also providing you the opportunity to study from the topmost educators all across the India from the comfort and safety of your home. Okay, so this is a very great opportunity. I think an opportunity like this would never have been possible except for this setup. And Unacademy has made a lot of effort to bring a lot of top educators on their platform, and you now have a chance to study from any one of them from the comfort and safety of your home. So how do you get this subscription and how do you avail all these benefits? Very easy. First, you'll need to install the Unacademy app. Once you have done that, you will go to the plus section of the app, select your goal as IITJ and click on that get subscription button. Now, when you do that, you'll be redirected to the payment page where now you will realize you can choose two kinds of subscriptions. One is the plus section, one is the iconic subscription. So plus subscription unlocks all the benefits of Unacademy Plus courses. You have access to all courses where you can study from all the topmost educators and be a part of any learning routine that you are comfortable with. Now, Iconic is the next step in your preparation. Iconic subscription will give you even more benefits, which we will talk about just in a bit. Now, when you're getting your subscription, you will have a box here which will say, do you have a code? So that is where you can use this code RD Live. That is my code. If you use this code, you will get a flat 10% off on all your subscription fees. Next, when you click on proceed to pay, then you will realize that you also have a lot of no cost EMIs for your payment options. So when you look at this, look at these prices. So for the plus subscription, I think the prices are very reasonable. You will realize that JEE subscription for 24 months roughly costs around 2,000 rupees per month, which is nothing compared to the kind of fees that people pay for their home tuitions for schools, for school subjects. Okay, so here you are getting professional help for your JEE preparation at such low prices. Okay, definitely worth the cost, the quantity and the quality that you'll be getting. That will be definitely worth the cost. So what are you waiting for? Go get yourself the subscription. Now, as I said, you can also now go for the iconic subscription. Now, this subscription will take your IIT preparation to the next level. You'll be allotted some personal coaches. You will be also be a part of a lot of IIT workshops along with your regular courses. Then you will keep receiving expert guidelines from time to time. You will have a study planner, and then you have test analysis sessions. So again, with all these features, you will not only prepare well, you will excel. You will get far ahead from the competition. Now, let me also remind you now, in case you are looking for a way to get these subscriptions for free, then that is what you can do here. You can take part in the Unacademy Combat. This is the most competitive and gamified version of the IIT JEE battle. Okay, so you can compete live. The next Unacademy JEE event, JEE Combat event, is going to happen on the 20th of December, and you can now enroll there using this code RD Live. Do well, and some of the top performers will get not only cash prizes but also Unacademy subscriptions absolutely free. So what are you waiting for? Go ahead, give this competition, give yourself a chance to get some free subscriptions. Okay. Those of you following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link, so that you're receiving all the notifications in time, and so that you're not missing out on any of the lectures or amazing sessions happening here on the JEE English channel. Now, without any ado, then let's get started with today's lecture. This is rigid body motion, and today we'll be talking about some advanced PYQs. Okay, let's begin. This is a very interesting problem that I usually like to begin with. So here, the actually problem was a subjective problem which I have converted into options. Okay, so that you guys can try and answer. So here, the situation shown is that a rectangular, rigid fixed block has a long horizontal edge. Now, a solid homogeneous cylinder of radius r is placed horizontally at rest with its length parallel to the edge, such that the axis of the cylinder is on the edge if the of the block. I think this should be off the block. Now, uh, so that the axis of the cylinder and the edge of the block are in the same vertical plane as shown. Okay. Now, there is a sufficient friction present at the edge so that a very small displacement causes the cylinder to roll off the edge without slipping. Then, and these are your options. So let's see. So try this, try this. This is a wonderful problem. So in case that diagram is not visible to you, let me maybe change the screen size a bit. So yeah, this is what your situation is. This is what the diagram is. Okay, I hope you can see the diagram clearly now. So there is a box here, and on the edge of the box there is a cylinder which is kept, and it is initially kept right at the edge, and now it rolls off without slipping. Okay, so you have to figure out what will be the following options. One of the following options. Which one of the following options will be correct? So option 1 says the angle theta through which the cylinder rotates before it leaves contact with the edge is cos inverse of 4/7. The option B says that the speed of the center of mass of the cylinder at the moment of leaving contact with the edge is root of 4 gr/7. Then option C says the ratio of the translational is to rotational kinetic energy of the cylinder when its center of mass is in a horizontal line with the edge is 2, and D says all of the above, and E says only A and B. So why don't you guys give it a try? And this is one of my favorite problems. Hello Motilal, how are you? And hi Amol Kumar. Good of you guys to join us. All right. So this, as I said, this was asked in JEE 95. This was asked as a subjective problem, but I think it's one of the very good problems on rotation, which is a must do for all students. That is why I wanted to discuss this today. So why don't you guys give it a shot? Okay. So let me know in the chat whether you're trying this or not, and if in case you want me to show you how to approach such problems, then also you can let me know. Okay, and we will talk about the solution. Okay, so first I want you guys to just give it a thought, try it for a bit, and then let's see. Okay, so have a look at the question properly again. Let's see, and if you want to look at the diagram, this is what your diagram looks like. Okay, so there is a cylinder which is kept right at the edge of a horizontal table. Okay, so this should be pretty easy to see, and there's nothing special about this diagram. All right, and here is the question for you. Try it. Let's see if you can figure this out. So again, this is a pretty standard question now that is usually discussed in most of the institutes. Okay, and this is a wonderful problem to help you understand how rotation works and how you can approach a typical standard rotation problem. Okay, so definitely give this a try, and then of course I will show you the solution. Okay, but before that I want you guys to give this a try. Okay, so let me remind you one thing. Like in rotation, I think it is very important so that you get enough practice with a huge variety of problems, because this is such a complex topic with so many concepts that even if you've studied this like thoroughly, then also chances are that you're going to miss out something or the other somewhere. Okay, so it is always good to get a lot of practice about rotation so that you get so thorough with your practice that you know exactly what to do and what not to do. Because trust me, half the times students know what to do, but they don't know when to do it and when not to do it. Okay, so what can be applied when? That is very important. So try this problem, try and figure this out, and maybe we can wait one more minute. Yeah, let's wait one more minute and then I will show you the solution. Okay, till then, you guys try and let me know your thoughts in the chat. Let's see what you guys think, how you will approach this. Good evening, Raj. How are you? So any thoughts you may have doesn't really matter. Okay, just if even if you want to uh, express how you think the problem should be approached, that is also fine. Okay, but definitely give this a try. This is a wonderful problem. Okay, one of my favorite problems from rotation, by the way. So can we have some attempts then? We have some attempts. I'm gonna wait for one more minute. That's it. I plan to discuss a lot of previous year JEE questions. Okay. All right. So that's it. That's it. I think I've waited enough. I don't know. I don't know. I don't think you people are giving it a try. Anyway, let's try and analyze the situation. So this is the edge of the table, and you have a cylinder. So let's talk about the side view. So when you're looking from the side, what do you see? So this is what you would have seen, right? There was a cylinder which is kept right at the edge, and you have been told that initially it is kept like that, such that its axis is parallel to the edge, is right above the edge. So the center of mass of this initially is right here. Okay, so this is a cylinder of mass m and radius r. And now you have been told what does the question say. So let's pay attention. The question says that it is initially placed at rest along the direction shown, and there is sufficient friction present at the edge so that a very small displacement causes the cylinder to roll off without slipping. So imagine now if you give this cylinder a small nudge, imagine if you give it a small push, small L push, what will happen? It starts to roll away, right? If something is right at the edge, you realize it'll try and roll away like this. So at some angle, after turning some angle, you will realize it will lose the contact. Okay, so let's try and figure out at what angle does it lose the contact. So what we will do is that we will try to analyze how the n is varying. So okay, so Tanya says it's D. Okay, so D is actually I think correct. All these would have been correct. Okay, but these are all great options. So we'll take a look at all of them one by one. Okay. So let's imagine after some time it has rotated by some angle theta. Okay, so imagine that this cylinder after some time has come to this position. Okay, it's still attached to this edge and it has just rotated like this. So yeah, spare me for my horrible drawing. I was never very good at drawing. So let's try this whole diagram once more. I want a very neat diagram for this. Let's hope this works. Seems all right. Okay, so this is the initial position. Let's assume finally the contact point remains the same and it has rolled like this. Okay, and here is your table. Okay, so imagine that this point, the center of mass is here, now has come here and it has rolled by some angle theta. Okay, so first I want to find what would the normal reaction be when it has turned by an angle theta, assuming it hasn't lost contact. Okay, since we know that it is performing pure rolling, so I know that it should have gained some rotational kinetic energy. Why? Because it would have lost some potential energy. Okay, as it turns, you realize the center of mass is coming down. Okay, so can I say since there is no slipping, so friction will not do any work and energy conservation can be applied. Okay, now I can say there is no slipping, since there is no slipping, energy conservation can be applied. Okay, so by the way, rotation is one topic that I like taking my time with because this is one of my favorite topics. This was my favorite topic even as a student. I know a lot of people will not understand this because I know most of you hate rotation, but trust me, as a student, this was my favorite topic from physics. So now what I can write is that if you see here the initial height of the center of mass was r. Now it has rotated by this, so this height is the height of the CM later. Okay, so this is r cos theta. Okay, yeah, r cos. Read. So let's see what is the potential energy lost. So potential energy lost by the cylinder would have been m g times r 1 minus cos theta. Right? It has come from a height r to a height of r cos theta. So the potential energy lost is this. This should be equal to the gain in kinetic energy. So gain in kinetic energy would be half. Now I can directly write this as half I about axis of rotation into omega square. Please remember, because there is pure rotation happening about this is pure rolling case, right? There is no slipping about this point O. So here, this point O. So the total energy can be written as half I about IAOR into omega square. So I can write this as half I about this point, which would be 3 by 2 mr square omega square. Okay. That is what energy conservation is telling me. With the help of energy conservation, I can find a few things. I can find the omega. I can also find the velocity of the center of mass. Okay, so let's see what this gives us. So this will give us that if I remove these, then what I get is omega square equals 4g over 3r1 minus cos theta. Okay, so when it has turned by an angle theta, this is the omega that we would have had. Now, if I draw an FBD of this in this situation, now let's imagine. Let's try drawing an FBD of the cylinder. What are the forces acting on it? So here is O. Here is the center of mass. This angle is theta. So I can have mg. First of all, mg would be acting the weight. So you will have mg acting on this like this, and then you would have had a normal reaction which would have passed through the center, correct? So there would have been a normal reaction and there could have been a friction. So let's assume that the friction is like this. These are the only three forces that can act on this, correct? Normal reaction, mg and friction. Now, if I write the equations for, if I take my x and y axes in these directions, so let's just choose ourselves convenient axes. Let's choose this as y and this as x. Okay, so the direction in which the normal is acting, that is what I'm choosing as y, and the other direction I'm choosing at x. So for the y direction, what can I say? I can say is that what is the net force acting in the y direction. So if that angle was theta, this will also be theta. So I can say for the y direction, let's enlarge this, and I can now say for the y direction, the net force summation Fy, how much will that be? That would have been n minus mg cos of theta, correct? Now, what is the acceleration of the CM? What is the acceleration of the CM? The acceleration of the CM would have been in this direction. Now, this is where it gets tricky. Your CM is actually rotating in a circle like this, correct? So it is rotating with the circle in a circle like this. It has some tangential acceleration. It also has a centripetal acceleration because it has some omega. So you will realize that the acceleration in this direction, the acceleration it has will be in this direction, and that will be omega square r. Correct. So next I can say for the y direction, summation Fy is coming like this. What is Ay? Ay I will write minus m omega square r. Correct. Why minus? Because it is inward. Okay, it is in the negative y. Plus y is this side is positive, this side is negative. That is what we are getting. So if I now write the F equals ma equation, so let's try and see what the F equals ma equation will tell us. So therefore, all I can say is that n minus this should be equal to this, or I can say n would be equal to mg cos theta minus m omega square r. Right? Now you will also realize from the above equation, omega square r was 4g by 3, 1 minus cos theta. So I can rewrite this as g cos of theta minus 4 by 3 mg 1 minus cos of theta. I hope you can see that. All I did was replace the value of omega square into r from there. Now I can further write this as, so what is my value of n? N turns out becomes that will be 7 by 3 m cos theta minus 4 by, okay, so if I take mg by 3 common, that is what I'm 7 cos theta minus 4. Correct. So this is the expression that I got for normal reaction. Okay. This is the expression that I'm getting for normal reaction. I hope everybody followed this. So what happens as the theta is increasing? You realize if theta was zero, then n was equal to mg. which should have been the case. So we are right in our calculation. That means, okay, now as the theta increases, you realize that the n will go down. Why? Because as the theta increases, your cos theta will decrease, right? At some theta, the normal reaction will go to zero. And that is when you can say that the cylinder loses contact with the edge. You should know this. Whenever the contact between two solids is lost, the n drops down to zero. So now I can use that situation, and let's say when the contact, let's write that, when the contact with the table is lost, n would become zero. So which means can I say that 7 cos theta minus 4 becomes zero. And that happens at cos theta equals 4 by 7, or theta equals cos inverse of 4 by 7. So that is the angle at which the contact gets lost between the cylinder and the table. Okay, I hope you followed this. What we did was we first applied energy conservation to calculate the omega, because I know as far as this is rolling without slipping, there is no work being done by friction. So all the kinetic energy in the rotation that the cylinder will gain will come from the potential energy that the center of mass is losing. Okay. So using energy conservation, I calculated omega square. Then I applied Newton's equations, and I said for the y direction, the Cm has a centripetal acceleration which is equal to omega square r. So I said the net force in the y direction should be equal to m minus m omega square r. With the help of that, I got n as a function of theta. So this is what I was getting my normal reaction in terms of theta. And I said, if I look at this expression, the normal reaction would go on decreasing as theta increases. So at what angle does this n become zero? I realized the angle for that is cos inverse of 4 by 7. And that is what your option number 1 is. In fact, your option number A is definitely correct. So this is a subjective problem, by the way. There they had 3 parts. So in the first part, they asked about the angle at which the cylinder leaves contact with the table. Okay, next let's see what it says. It says the speed of center of mass of the cylinder at the moment of leaving contact with the edge. So speed of Cm has been asked. So I already calculated the omega at any theta, right? So here I knew how to calculate omega at any theta. If I know this, now I can calculate VCM also. Okay, so let's write this down. So let's find omega. So at this instant, omega square would have been, if I recall the equation, it was 4 by 3 G by R, 4 by 3 over R, and then I had 1 minus cos theta, right? Now cos theta I just calculated is 4 by 7, so I substitute that value and I'm getting omega square as 4G over 3R times 1 minus 4 by 7. So what I'm getting is 4 by 3G over R into 3 over 7. This is what I'm getting. So omega square equals 4G by 7R. So if I had to find the V, what I would have done is omega becomes equal to root of 4G over 7R. And I would have realized V would have been omega times R. Why? Because there is a rolling happening without any slipping. So V equals omega R would be applicable, and VCM, how much will that be? This will be root of 4GR over 7. Okay, let's see what the option B said. 4GR over 7, in fact. So this is also correct. Okay. Next is an interesting part which you often do not realize, because that is not asked in a lot of questions, and that is why I wanted to take up this question. So this asks you another very, very interesting thing. It says what is the ratio of the translational as to rotational kinetic energies when its center of mass is in horizontal line with the edge. Okay, so you have to find that. Now, here is the interesting part. Once it has left the contact with the edge and once it has started rolling off, now how do you think the motion would have happened? Now, this is an interesting thing. So you have to visualize it a bit. You have to think about it a bit. So let's imagine at some angle, this has lost contact. It just loses contact. It's just here, just about losing contact here. Okay. So at this time, it would have had some VCM like this, which we just found. Okay, it would have had some omega. Now you will realize because you have a VCM like this, and there is acceleration due to gravity downwards. So what kind of path would the CM take? Imagine. So CM would have taken a path like this. Right. So while taking a path like this, at some instant, the CM would have landed in this line. Okay, when it would have become horizontal with the edge. So let's draw a diagram here. So imagine when after rolling, it comes here, the CM reaches here. Okay, now what have you been asked? You've been asked to find the ratio of the translatory kinetic energy and the rotatory kinetic energy. Now you have to realize one very important thing, that here, what was the height of the CM? It was r cos theta. Okay, and here the height of the CM is 0 if I take this as my reference point. So from r cos theta, it has come to 0 height, so it has lost potential energy. But do you realize the only force acting on this when it is in the air? So in this entire duration, the cylinder would have rolled in the air, right? It would have been moving in the air, and in the air, the only force that our cylinder is feeling, that will be mg. Agreed. So you realize if you took the torques about the center of mass, there is absolutely no torque. Earlier, who was providing the torque, which was ensuring that you're getting omega? It was the friction. If you talked about torques about the center of mass, the friction force was providing a clockwise torque, which is causing the clockwise rotation. Now, from position 1 to 2, so if I name these positions, let's call this position 1 and let's call this position 2. So I can say between positions 1 and 2, there is no torque acting on the sphere, the cylinder, with respect to the CM. So if there is no torque, so there will be no alpha, which means the omega will not change. I hope you realize that that is a very interesting thing which you really have to think about, and that is what I find is something very conceptually beautiful about this question, because a lot of students don't realize this. I think I had shown a demo also of this kind of thing, that if you realize that if you do something in the air, I don't know if I have something which I can rotate right now, maybe this. So here is a capacitor, by the way. This capacitor I kept for showing you guys. Okay. So if I rotate this and if I am throwing this in the air, you realize its rotation never changes. Even at the highest point, its velocity becomes zero, but it's still rotating. Why? Because there is no torque acting about the CM. So for the entire duration that this object remains in the air, if I give it some omega while flipping it up, then that omega never changes during the journey. Only the VCM changes. Okay, so that is what you need to realize. So let's write that down. While the cylinder is in air, there is no torque about the CM, and therefore its omega never changes. So omega at position 2, that will be, this is where I am saying that let's imagine that here the velocity of the CM has become some v dash and the omega has become some omega dash. So I can say omega is equal to the same omega which it had initially. That is what I'm saying. Therefore, omega dash equals omega, which we calculated in the above equation as a root of 4g over 7r. Okay, so omega I've already got. Next, what I want to do is I want to calculate the v dash. Now, will this velocity of the center of mass change? Think about it. Yes, that will. I just showed you the example in which I rotated this capacitor in the air. So its VCM was changing throughout. Why? Because of the force of gravity. And can I calculate how much it has changed by? Yes, that can be done by using energy conservation again. You realize from position 1 to 2, the energy, there is no non-conservative force, so the energy of the system should remain conserved, right? So also applying energy conservation between 1 and 2, in positions 1 and 2. Now you notice one thing, that from 1 to 2, all the potential energy being lost will go into the translatory Ke only. So the change in translatory Ke would be equal to the loss of potential energy. Therefore, I can say what is the potential energy loss? That is mgr cos theta, and this should be equal to half m v dash square minus half m v square. Correct. So from here, I can find the half m v dash square's value. Half m v dash square becomes half m v square, which we just calculated as 4g over 7r. This is v square plus you have mg r cos theta. Cos theta was again 4 by 7. Okay, we just wrote that. So half mv square in fact becomes 3 by 2. So that is 6 by 7. So 3 by 2 times this, so that is 6 by 7 mgr. Okay, so this is the translational Ke. How about the rotatory Ke? Rotatory Ke would have been half ICM, which is mr square over 2 into omega square, would have been 4 by 7 g over r. Okay, so what you would have noticed is that this is what it is coming out to be. So rotational Ke in fact comes out to be mgr over 7. So the ratio between the translatory kinetic energy and the rotatory kinetic energy is in fact a 6, not 2. Okay, so that was incorrect. So let's see if we had another option. Yes, so option E is correct. Okay, because this is wrong. This option is wrong. The ratio is not 2. So 2 is wrong, because of which D becomes wrong and E is the correct answer. Okay, I hope you guys followed this. So this is a very long problem. This was a subjective problem, and that is why it takes a lot of time. But trust me, this problem is still worth solving just to understand the concepts. Okay, if you pay attention, you will realize a lot of concepts, how you would have approached different things. Okay, I hope everybody followed this. So these are the answers, and that is how you would have approached such a problem. If you have any doubts regarding the approach, you can let me know in the chat. Okay, and I will clarify that. Let me know. So let's go over this also. Okay. So I said, first of all, for losing contact, the n has to be 0. The condition for n to be 0 comes out to be cos theta equals 4 by 7. Then at that instant, I already knew omega at any theta. If I have substituted the value of cos theta as 4 by 7, I found the omega and hence the VCM also at the time that the contact was lost. So if I knew the VCM there, I can find the final VCM also when it becomes horizontal. So from the position of losing contact till becoming horizontal, I realized that there will be absolutely no change in omega because there is no external torque. So all the potential energy lost would be going to the translatory Ke, in fact. Okay, so because of that, I find the final translatory key also. Okay, and this is what we are getting. So the translatory K at the end is coming out to be 6 by 7 mgr, and the rotational K remains unchanged. Okay, so that'll be half ICM omega square. Okay, so if I put that half into ICM would be mr square by 2, because this is a solid cylinder, into omega square. Omega already we know is 4g over 7r rooted. Okay, so if I substitute all these values, then what I'm getting is I'm getting rotational K as 1/6 of the translatory K. So option E was correct. Okay. Again, let's go over another problem which was asked in the JEE Advanced. So this problem says a cubical block of side L rests on a rough horizontal surface with coefficient of friction sufficiently high so that the block does not slip before toppling. Okay. The minimum force required to topple the block is, so this should be easy. Okay, this should be easy. This kind of problem I taught to you earlier only. Okay, so this should be super easy. What will be the minimum force required to topple this? So think about this, and this should be easy. So again, these are the previous year JEE advanced questions. I haven't picked up all the questions. I'm only picking up a few select questions, and some of the trickiest I have left. Okay, so three trickiest problems I have left out from today's discussion. I will be having a special session for those three problems, because trust me, those three are the most controversial and the toughest problems that have been ever asked in a JEE. Okay, so those problems we'll be discussing later. Till then, let's go through the standard problems that JEE likes to ask, and let's see what kind of problems you can expect from JEE Advanced and how to approach them. Now, if you can solve these problems, JEE Mains is already taken care of. Okay, so trust me, JEE Mains problems would be simpler than this. So okay. So AP says C. So let's see. Let's see if that is correct. All right. So this should be easy. If you attended the last lecture, I told you that how do you do this. So all you need to do is imagine the condition for toppling. So make the FBD. So here should be mg. Then there should be a force normal reaction, and then there should be a friction. Okay, and then there would be a force F. Right. So now all you need to do is take torque about this point O. So you would have realized that the as this force F is applied, the N would start to shift. Okay, so as N shifts, so you realize N can maximum shift to here for toppling. For just toppling, the N would have shifted here. Okay, and if after shifting to the maximum possible edge, also if the N cannot balance the torque of F, then the toppling will happen. That is what we realized, right? So that is what we are going to do. Taking talks about what we realize is for toppling, the torque of F should be greater than, so F into L, which will be the torque of F, should be greater than N times L by 2. Okay, and N was equal to mg for from translatory equilibrium. Okay, so from here I will just realize that F should be greater than mg by 2. That's it. So if m is greater than mg by 2, then the toppling will happen. So yes, uh, you were absolutely correct, AP. Well done. Okay, so this is an easy one, standard one. Okay, so here is another toppling problem. Okay, so JEE has asked a lot of problems from toppling also. Okay, so I think some part of this not visible here. So let's just adjust this so that you can see the entire option. So here now you should be able to see all the options. Okay, so this one says now that a block of base 10 centimeter by 10 centimeter and height of 15 is kept on an inclined plane. Now the coefficient of friction between them is 3. Now the inclination theta is of the inclined plane is increased from a horizontal plane with the horizontal plane is increased gradually from zero. Okay, then there are your options. So option A says that at theta equals 30 degree, the block starts sliding down the plane. Option B says the block will remain at rest on the plane up to a certain angle theta and then it will topple. Option C says at theta equals 60, the block starts sliding down the plane and continues to do so at higher angles. And option D says at theta equals 60, the block starts sliding down the plane and on further increasing theta, it will topple at a certain height. Okay, so what do you think is the answer for that? Yes, yes, yes. We already solved the last question. I think you guys are giving the answer to the previous problem. So let's try this. This is another problem from toppling. Now, for your hint, the FBD at just toppling has been told to you. FBD at just toppling has been told to you. I told you when the weight is causing the toppling, then all you need to realize is that if the torque, if this line of action of mg, if it remains like this, then there is no toppling. The moment it crosses this, it topples. So at just toppling condition, the mg should pass through the edge. Now, does this remind you of another question? Exactly a very similar question was asked in JEE 2020. So if you would have solved this, then you would have solved the JEE 2020 question like very, very quickly. And that is why it is very important to have practiced previous year problems. Okay. Because trust me, almost a very, very similar problem, at least the approach would have been similar, was asked in JEE 2020. So if you would have solved this, then you would have been clear about the approach. Okay, so let's see if you can figure this out. So I hope you remember how you used to calculate the possibilities. There are two possibilities. Either there will slipping happening, sliding that will happen before toppling, or toppling will happen before sliding. Right? I told you how to calculate both those conditions. So use those conditions and try and answer this. Okay. Let's hurry up. Think about this. Give it some time. Don't worry. Don't worry. So it should be pretty easy by the way. What do you think is the answer for this? So try and find the answer. What do you think is happening first? First of all, do you think the toppling is happening first, or do you think the slipping is happening first, sliding is happening first? What do you think out of these two is happening first? If you can figure that out, then you can easily answer this. Okay. Okay. So AP says B. All right. Let's see if AP got this correct. So okay. So let's just this back. And now you know that this is the incline. Okay, and we made this box, and we told you that at this toppling, this guy he should pass through here, right? Should pass through here. This should be the diagram for FBD for toppling, and you told that if this is theta, this will be theta, right? And this is the angle. This side would be 5, and this side would be 15 by 2, so that's 7.5. right? Because the dimensions of the body were 10 by 10, that was the base, and the height was 15, right? So these will be the sides. Okay, the CM will lie exactly at the center. So can I say if the angle increases more than this, then toppling will occur? Okay, so let's find the condition for toppling. For toppling, for just toppling, for just toppling. Theta, I can see from here, from this triangle. So let's make give this names. This triangle, let's call that C, and let's call some other things also. Okay, so let's call this O, let's call this A. So in triangle, I can say in triangle OAC, what would you notice? You would notice that tan theta, how much will tan theta be? Will be 5 over 7.5. So that is, okay, so into 2 by 3. So if tan theta becomes 2 by 3, then we have the condition for just toppling. Okay, so therefore, toppling happens if theta is greater than tan inverse 2 by 3. Okay, I think here it should have been root, because then the options make more sense. It should have been root 3. Okay, if the coefficient of friction is root 3, then you will realize that condition for just slipping, for just slipping, you guys should remember mu should have been, or tan theta should have been equal to mu, which is root 3. Now, root 3 obviously is more than 1, and this obviously is less than 1. So, do you realize that this angle would be less than 45 and this angle is 60? So, slipping would have happened at an angle greater than 60. Okay, so therefore, sliding happens, sliding happens if theta is greater than 60. So, I got the conditions for both. Now, I realize that the condition for toppling is being achieved beforehand. So, yes, option B would be correct. Option B says the block will remain at rest on the plane up to a certain high angle theta, and then it will topple. The sliding won't even come to the sliding condition. The toppling will happen before. Okay. So option B is correct. Very well done, AP. All right. Now let's move on to another very interesting problem. This was asked in JEE 2011. Again, I've picked up some of the very interesting problems that I found and that I find you must practice. Okay. So you've been told a boy is pushing a ring of mass 2 kg and radius zero point 0.5 meter with a stick as shown in the figure. Now the stick applies a normal force of 2 Newton on the ring and it rolls without slipping with an acceleration of 0.3 meter per second square. Coefficient of friction between the ground and the ring is large enough that rolling always occurs. Okay. So on the ground you have sufficient friction available so that which will ensure that the rolling on the ground will always occur. So you have to find now the coefficient of friction between the stick and the ring. And here are your options. Again, this was an integer type question. I think you have to find 10 times mu. So that would have been an integer. And here is this. These are your options. Your options are zero point 0.2, 0.4, 0.6, or is it 0.8? Think about this. And let's see. This is again a very interesting problem. So you should realize the level of problems that JEE asks. These are not easy problems. So you do need to get some practice. Okay, just HC Verma is not enough for solving these kind of problems. Trust me, you would have had a lot of trouble. Think about this and let me know. Okay, so B. Okay, let's see. How about others? How about others? Does anybody else have any other ideas? So let's see how you would have solved this. Again, this is a very tricky problem. So when you think about this, think about this. What is happening? I don't know if I can make shapes out of this. Oh, this is different. Okay, we will just have to stick to my own drawing. Supposedly, I can't draw shapes with the help of this. So anyhow, imagine that this is the case. So this is a ring, right? So let's see. Yes, the ring. Stick applies a force of 2 Newton. And 2 Newton, by the way, they should have said is the normal force. So here, yeah, applies a normal force of 2 Newton. That is good. So here is a stick. I think in the J question they did not mention that 2 Newton has to be the normal force. Because if you talk about the net force applied by the stick, it would have been the sum of friction force and the normal force, right? Should have been careful, and IIT should have mentioned that. So let's imagine what are the forces that will act on this as this stick is pushing it. What are the forces that you can see acting on? So first, of course, you will have this mg, right? The weight of the ring, and then you will have a friction from the ground, and let's assume that the friction is in this direction, and let's call this F1. So I'm only assuming this friction to be in this direction, okay? F1. Now from the stick, I will have another friction and a normal reaction and a normal reaction from the ground. So from the ground, let's make a normal reaction. Okay, let's call that N1. Now let's also assume that this stick is pushing it with some other normal reaction, and let's call that N2, which I know is 2. N2 equals 2 Newton. And then let's also assume that there is one more friction acting like this, or maybe in the opposite direction. I think about the direction one bit. Let's imagine that this was the state. And when the ring starts to pure roll, you would have realized that would have had this kind of an omega. If it has this kind of an omega, so this point with respect to the stick would have been moving upwards. So you would have had a downward friction F2. Doesn't really matter if, even if I took it upward later, I would have gotten a negative value, but still, when I can get the judge the direction, shouldn't be a problem there. Okay. Even if I took it upwards, I would have gotten a negative answer, so that would have taken care of things in any case. So Asha Rani says, should we do short notes after each lecture after completion of full chapter? No, after every lecture, I think you should. After every lecture, you should. It makes sense to do it after every lecture. So in fact, this is something that I wanted to discuss. So good of you to bring it up, Asha. So let me tell you this, that this is the routine that you should follow. This is the kind of routine that I would follow. I used to follow, and trust me, it works. Okay. So first, so if you really want to study online and make the most of it, this is what you should do. So step one, watch all the lectures live. Watch a lecture live, and of course attentively. Okay, so make sure you're doing that. Okay. Why? I'll tell you. Why do you want to watch the lecture live? If in case there is some part of the discussion that you're not following, then while you're watching it live, you can immediately ask me questions and ask me to clarify that, right? But if you did not watch it live and if you're watching the recorded one, then if there was some part of the discussion that you do not follow, some explanation that I gave, but you did not understand, then you won't have the chance of asking me to clarify that, right? So first step should be this. Okay. Now, during the time that you're watching this lecture, you don't need to make the notes. If you do make notes, then it is well and good. Even if you just watch it very attentively, then also it should be fine. So either make notes while watching the lecture, but I don't know, sometimes you don't have enough time, watching the lectures to pay attention properly and also keep writing. So I would advise that for the duration of the lecture, you can avoid writing also and you can just attend it, pay attention to everything and ask a lot of questions. Okay. Attentively and interact. Let's just add that also. So that is what you do during the lecture. Now, right after the lecture, this is what you should do. Watch the lecture maybe in 1.5x. Watch the lecture again in 1.5 to 2x speed and make short notes. So what that will do is that will help you revise the lecture quickly. So right now you attended this lecture after maybe sometime in the evening, maybe within a couple of hours. This is what you want to do. Watch the lecture again. You can now watch it at a 1.5x or 2x speed. Keep on pausing it and making your notes. Okay, so that will make sure that you're making proper notes also. You're not missing out on anything important that you feel is being told in the lecture, right? And then step 3 should have been that you should now practice. Step 3 would be practice some questions. Now, as far as practicing is concerned, I would advise at least 15 problems a day, and that's not asking much. Okay, that's not too much pressure on you guys. There would be some people who would say that you have to solve 50 problems daily. I won't ask you that. I would definitely want you to practice at least 15 problems. Okay, what should be in short notes? So, see, any important thing that you want to remember, because when it comes to revision, you want to have your short notes and anything important that when you take a look at that you can remember the every concept, important concept regarding that. That is how you should make short notes. Whatever you find important about the lecture, whatever you find I need to definitely remember, and some things might be obvious for you, so those things you may skip. That is why the short notes is a very personalized thing. All the definitions, important definitions, definitely. If there is any important derivation, then definitely. All the important formulae, definitely. For as far as explanations are concerned, any important key explanation that you think, okay, this makes sense, and if I write this explanation down, then the moment I read this explanation, I will remember how everything works. Okay, so those kind of things. That is what you should write in your short notes. Okay, because the idea is just before the exam, you won't even have the time to watch the entire videos again, right? So then you would want to have extremely short notes which are personalized for you, which you can just go over in like 5 minutes and revise all the key ideas. Okay. And then, of course, step 4 is in fact ask doubts in the very next class. Do not leave doubts for later. So that is one mistake that students do, doubts in the next class. And that is why I want you to make your lecture notes for every lecture, not after the entire chapter. Because when you are making it after the entire chapter, and then if you start having doubts later, maybe it happens, trust me, to students. है ना, they say कि सर जब यहाँ सुनते हैं सब समझ में आता है. So we understand everything when you're teaching us. But when we go home and when we go over it again, then we start forgetting the explanations. And then things don't make sense. So that is why while making notes, you have to ensure that everything in the lecture made sense to you. And if there is any doubt, which you may also realize while practicing questions, you immediately ask in the next class. Okay, I hope that answers your query, Asha Rani. Okay, maybe I'll take a small session also on how to make short notes of lectures. Okay, so maybe that will help you with some more detailed things. But trust me, this is what you want to do. This is what I would do as a student. Whenever I would come back from the class, of course, we did not have the option of watching the lecture again. So I would have had to, make my notes while attending the class. But after coming back from the class, I would always take up my notes and, revise them and maybe remember if I want to add more key points to my notes for my own understanding. Okay, so I could even write something in my own language, even if teacher did not say that. Okay, because if I understood something and I want to write it in my own language, I would do that. And then I would practice questions. And then if I had any doubts, so first of all, I wouldn't leave doubts for later. Okay, so any doubt that I had, I would really pay attention to the lectures. Any doubt that I had, I would definitely ask my teacher in the lecture only. Okay, so that it is clear. And trust me, once you start building a habit like this, then there is a lot of wonderful things that you will realize. First of all, your topics will run at a good pace. In our college, recorded lectures are sent. What can I do? Okay, so you can any topic that you're having trouble with, any topic that you think you're not following well, you can you attend those lectures on YouTube. There are so many lectures available on YouTube. No, these days, Asha. So make use of the resources that you have. You have such unlimited resources. So I told you, follow an educator online and ask them for doubts for whatever topics are troubling you. For instance, you can come to my lectures if suppose something about fluids is troubling you. So whenever I'm taking fluids, you can attend my lecture live and ask any doubts that you have about fluids. Okay. So you guys have a lot of opportunities, trust me. You guys have such opportunities to study and make your preparations do so much better. Yeah. Make use of that. Okay. And that is it for that. I'll probably host another session, special session for that. Okay, I'll plan that soon. Good that you pointed that out. Now, in this particular scenario, let's see what it says now. It says that the acceleration of the center of mass is 0.3 meters square, meter per second square. Okay, and you've been told that the friction is large enough that the rolling always occurs. So if I know the acceleration of the CM, if I know the mass of the ring, if I know the radius of the ring, I can also find the alpha. So alpha and ACM are not known to me. Okay. So I know mass of this ring M. Go back to black. M was 2 kg. Right. What was the radius? Radius was 0.5 meter. And I know ACM is zero point 0.3 if I'm wrong. Wrong. Yes. 0.3 meter per second square. That's the ACM, right? Now, if you know the ACM and if you know that pure rolling is happening, you can also find alpha, correct? So I can say since pure rolling is happening, I know that alpha would be ACM over R. So I can also find that out now. So that will be 0.6 radian per second square. So I found myself ACM and alpha. Okay. Now all I need to do is write the Newton's laws equations. So yes, AP, this may appear to be tough, but trust me, if I show you the solution, it will be really easy. So what you can do is the easiest way of solving this is, since all you are asked is the coefficient of friction between the stick and the ring. Okay. So and what are the forces that you know? You realize we do not know N1 until we know F2, right? Because for balancing all the vertical forces, N1 will have to be mg plus F2. Okay. Similarly, I don't even know what F1 is. For F1, I'll have to write the ACM equation in the x direction. Now, one thing I know very, very easily about alpha. So I can take torques about any point. So if I choose my point smartly, so let's choose this point. Think a little about this. Think just a little about this. Okay, and then trust me, you'll be so happy that this problem can be solved. This really tough problem, looking problem can be solved in one go. If you took torques about this particular point O, then about O, which are the forces that are producing torques? It is two forces, which is N2 and your friction. Now N2 you already know. So I hope if you know N2, then F2 can be calculated. So that is what we are going to do. So it's all about identifying the right approach. So this problem can be solved with a lot of other approaches also, but they would be very inefficient, very, very long, very time consuming, a lot of calculations involved. But if you took, the first thing you did was took torques about O. First calculated the alpha and then took torques about O. Then trust me, let's see the solution now. Okay, so I can say that taking torques about O, taking torques about O, what do we see? So I will have a torque which is anti-clockwise due to N2. Anti-clockwise torques we take as positive, so I can write plus 2 into the radius, which is 0.5. And then I'll have a clockwise torque due to friction, so I can say minus F2 times 0.5 again. And this should be equal to I about O, because this is a ring, which will be 2mr square. So 2 into m into 0.5 whole square times alpha. Agreed. That's it. In one line, I have F2 now. I can cancel this and this gets cancelled. And what I get is F2 equals 2 minus mass was 2 and into 0.6. So that is 0.8. So F2 I am getting as 0.8. Okay. Now F2 if I'm getting as 0.8, I know this very, very easily now, since there will be slipping happening at this point. Okay. If I call this point A, so let's see this point. If I give this point some name A, I know at A slipping is happening. Now, if slipping is happening, then what is the force of friction? Force of friction would be the kinetic friction, which will be N2 times mu. So I can say that which F2 would be equal to N2 times mu. So, and that is 0.8 and N2 was 2. So mu comes out to be 0.4. Okay, so this is how you would have solved this. Again, if you thought a little and if you applied the right approach, then you will realize, yes, Karthik, mu is 0.4. If you applied the right approach, then you realize there is hardly any calculation that I had to do. All I needed to do was draw the FBD, figure out the alpha, and then take toss about O. Then in a single line, I'm almost getting the value of the friction. And the moment I have value of friction, getting the coefficient of friction is super easy. So this is my correct answer, B. And trust me, with enough practice, you could have solved this question in less than 1 minute. Okay, I have to write so many things, I have to discuss it with you. That's why it takes a bit of time here. Okay, because I have to explain to you, if since this is an objective paper, you don't even have to show the solution. Okay, so if I was given this paper, I would have immediately said, okay, ACM is this, alpha is this, let's take talks about O. All that would have been completed within 1 minute. Within 1 minute, you would have had the answer. Okay. So again, alternatively, what some others could have done was wrote all the equations for x directions motion, all the equations for y directions motion, maybe taken the talks about the CM. Okay, that would have been a very lengthy solution. Okay, but this is a shorter way. So try to see what are the forces that you're trying to calculate and which is the best point to take torques about, which will eliminate a lot of unknown forces. Okay. When you're taking torques, you realize if you choose the point of taking torque correctly, then you can eliminate torques due to a lot of forces. So whenever you want to do such a problem, what you want to do is select a point, a right point, which eliminates all the forces that I'm not interested in and involves the force that I want to calculate. Can these lectures be helpful for NEET also? Yes, absolutely. If you can follow this, then trust me, NEET would be easier. NEET is easier than a JEE, right? If you are able to solve a JEE questions, if you're able to understand the concepts. So eventually it's everything is concepts, right, Karthik? If you have your concept strong, you will in fact do very well in NEET. Okay. So yes. Now let's take another look at another question that was asked in JEE 2012. This is a very, very simple standard kind of a question where you've been told a lamina is made by removing a small disk of radius 2r of diameter 2r from a bigger disk of uniform mass density and radius 2r as shown in the figure. The moment of inertia of this lamina about an axis passing through O and an axis passing through P respectively have been told to you. Both the axes are perpendicular to the plane of the lamina. What is the ratio of IP is to IO to the nearest integer? Okay. So Karthik, I think see, I never prepared separately for JEE Mains, never separately for JEE Advanced, never separately for boards. My idea was just focus on the concepts because the physics is the same, right? Whether it is boards, whether it is mains, whether it is advanced. So if you get all your fundamentals right, and then you practice all sorts of questions, you practice all sorts of questions. So you probably don't need to practice those difficult questions that I keep talking about, which you need to practice for advanced. But for mains level, I think the level for physics in NEET is okay enough to be compared to mains. Okay, so whatever practice people do for mains, that practice would really help you in NEET also, and the concepts will help you no matter whether it's NEET or boards. Okay, so trust me, I got good marks everywhere. Okay, so in my boards, I think I managed 92% marks when I was a kid, which is a long time back. Back then, 92% marks used to be a big deal. Okay, now these days, I know a lot of you guys like get insane percentages. Yes, sir, you taught physics, right? Yes, thank you. All right, so how about this one? How about this one? Let's talk about this. So let's try and calculate I about O and I about P. So you have this disk, which has this smaller disk removed. So I about O would be I about O of the bigger disk minus the I about the O of the smaller disk. So to say, so I can assume that this is made up of a big disk of radius 2r and a disk, small disk of negative mass of radius r. Right. So this is point O, and here this is point O. So the net moment of inertia of the object shown IO would have been I of O of this full disk plus I of O of this IO1 plus IO2. Okay. So let's calculate those. So let's imagine that this has some mass. Okay, so this would have an area of 4 pi r square, and this would have an area of pi r square. So if the mass of this was m, then the mass of this would have been 4m because it would have had 4 times the area. I hope you realize that. Correct. So let's uh, assume the masses to be m and 4m. So what I1 would be, I1 would have been 4m into 2r whole square by 2. Okay. Because O is the axis passing through HCM, so I know the ICM is mr square by 2. And then I would have had this of minus m mass. So then for the moment of inertia of this, now for this, the axis is passing through the edge, so it would have been 3 by 2 m r square. Correct? Let's see what is the total that we are getting. The total that we are getting is, in fact, if I just leave this 2 a bit, so here I would have had 16, 16 minus 3, that is 13. So the answer is 13 by 2 mr square. Okay, so that's my I about axis O. Okay, how about I about axis P? So again, I will apply the same approach. Okay, it will be very, very simple. I about P would be IP1 plus IP2. So for 1, it is an axis which is passing through the edge. So here is your P. So IP1, how much will that be? IP1 would have been, in fact, 3 by 2 mr square. So m would have been 4m to r square, which would have been 2r whole square. So this would have been the moment of inertia of the bigger disk about an axis passing through P, and the moment of inertia of the smaller disk. Let's take a look at that. How much will that be? So minus times we would have had. So the distance from here, this is r, this is 2r. So what is this distance? This distance would be put 5r. Right? root 5r. So I can again apply parallel axis theorem. Okay, so if I apply parallel axis theorem, then I can say minus mr square by 2 plus 5mr square. Okay, so let's see what we are getting here. So here I will have 16, 16. So 16 by 2, that is 8. 8 into 3, that is 24. Here I have 24 mr square minus, then I would have had this 10, 10, 11. 11 by 2 mr square, right? So eventually I would have gotten 48 minus 11. So that would have been 37 by 2 mr square. Okay, I hope you can see that. Now what has been asked you is the ratio IO is to IP, right? So IP is to IO. IP is to IO. Realize what will that come out to be? That will come out to be, that was 13 by 2, this is 37, so 37 over 13, which is roughly around, okay, 39 over 13 would have been 3, right? 37 over 13 would be close to 3. So the nearest integer, so that is going to be our answer. Yes, Karthik, very well done. All right. Great job. So trust me, if you're solving advanced problems of a G, then you will really do very well in your NEET. And trust me, I have also had experience of teaching a little bit of NEET. What I realized from there is that most of the students, NEET students, they always do very well in biology, all of them, and most of them do well in chemistry also. The major pain point for all NEET students, I think, becomes physics, right? So if you're doing well in physics, then you can be assured that you will get one of the top ranks. In fact, that is the differentiator in the ranks. So people who do not get top ranks to medium ranks, the difference is physics. For NEET, physics creates all the difference. Okay, so very well done. I think you are going great. Now let's talk about the JEE Advanced 2012 problem. Again, this is a very conceptual problem, simple problem, no maths, no calculation involved at all, but a very conceptual problem. And JEE still likes asking conceptual problems. That is why having strong concepts is still the need of the hour. A lot of people don't want to pay attention to the theory. A lot of people don't want to pay attention to the basic. They just want to get downright to problem solving. Sir, tell us formulae. Tell us how to apply this in problems. What will I do after understanding theory? Right? If I know this is the question, this is the formula, I can solve it. But no, he wants you to have a thorough understanding of your concepts also. Yes, I'm sure you do. All right. Why again? See, why are you taking such a paper? Because eventually, after you go into IIT, you are supposed to do engineering. In engineering, you'll be applying all this knowledge. So if you don't understand what you're doing right now, trust me, you will have a lot of trouble in IITs or your engineering colleges also. Okay, so that is why it is also important. This will not only help you, a good thorough understanding of your subjects will not only help you crack the JEE, will also help you perform well in your colleges and in your entire career for that matter. It may help you. Okay, so here is the question. It says a small mass m is attached to a massless string whose other end is fixed at P. So you can see here is a point P. Here a string is fixed, which has a mass m attached to the other end. Okay. Now it says the mass is undergoing a circular motion in the xy plane. So you can see that this is the xy plane, that is the z axis. So this is how the plane looks like. The mass is moving in a horizontal plane, which we are calling the xy plane, and with a constant angular velocity omega. Now you've been told if the angular momentum of the system calculated about O and P are denoted as L about O and L about P respectively, then okay, so see, I think because the net torque is not equal to 0. Okay, let's take a look at the options. So A says LO and LP do not vary with time. Okay, so let's see. So when does the torque does not vary with time? If there is no torque, when does the angular momentum does not vary? If there is no torque about the given point. So L about O would not have varied if there was no torque about O. So is there torque about O? First of all, think about this. Think about this. So there is mg and then there is tension. So tension can be divided into two components, this and this, right? Now you realize this component, if this is theta, this is theta, then T sine theta would be balancing mg. In fact, T sine theta would be balancing mg. That is why it is moving in a horizontal plane. Otherwise, if there was a net force in the y direction, it would have had a y acceleration. So I can say T sine theta definitely is equal to mg. I hope you agree. Now, the only net force is T cos theta. But T cos theta will pass through the center. In fact, that is the centripetal force for the circular motion. So that does not produce any torque about O. So when I'm talking about M, I realize torque about O on M is 0 in fact. So I can say L about O will be constant. Absolutely. How about P? If I talk about point P, then you realize then mg is definitely producing a torque. Yes, at P, net torque is equal to 0. No, 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 no. Net torque is not equal to 0, Baba. At P, you realize at O it is 0. Yeah, yeah. At P, you realize mg is producing a torque. At P, you realize the two forces are, so one T is passing through this, and then you have mg. So this mg ends up producing a torque about P, and that is why the angular momentum about P would vary. Okay. So LO and LP do not vary. That is wrong. LP turns out will vary. LP is not constant. Why? As tau about P is non-zero. So then option B says LO varies with time, but LP remains constant. This is again wrong. C says LO remains constant while LP varies with time. That is correct. So yes, well done, Karthik. C was the correct answer. Very well done. Okay, so again, this is another slightly tricky problem. This maybe you can try later because we are running out of time. You can try this problem later, and you can check out the answer online only. Okay, because I don't really remember. Yeah, I figured that. I figured that. Perfect. Okay, this was another very interesting problem. So I'll quickly tell you how to solve this. Then you can try this later. So you've been told two identical uniform discs roll without slipping on two different surfaces A, B, and CD, starting from points A and C with linear speeds of V1 and V2, always remaining in contact with the surfaces when they reach B and D. The linear speeds are this and this. So V1 is this and V2 has been asked. So energy conservation, use energy conservation and you will be fine here. So that is a very straightforward standard kind of a question, which you can easily find by using energy conservation. Uh-huh. Okay, so use energy conservation in this question. This will be really easy. Then you are asked a rigid uniform bar AD of length L is slipping from its vertical position on a frictionless floor at some instant of the time. The angle made by the bar is theta with the vertical, which is the following is wrong. So since the floor is frictionless, you would have realized that there will be no force acting on the bar in the x direction, right? If there is no force acting on the bar in the x direction, the CM would have fallen in a straight line. Okay, because the only external forces would have been mg and n, both are vertical forces. Okay, so yes, it would, the midpoint of the bar will fall perfectly downwards. So that is correct. Then the trajectory of point O is a parabola. That you need to figure out. Okay, so how will the trajectory of this will be? So all you need to do is find out the velocities and then integrate. Find out the x velocity, find out the y velocity. So how do you do that? You find at any angle you find the theta, the omega. Okay, so after or what you can do is you can find a relation between theta and t. And once you have theta and t, then you can find out the relation between x and y. Okay, I don't even think for that you will need any analysis, right? So let's assume in fact if this was at any height h from the ground and this is L by 2, L by 2. Then the x and y coordinates can be written, right? So yes, you have to find theta as a function of x and then write x and y coordinates in terms of this theta, and then you can find a relation between them. Okay, that is what you have to find. Okay, so everything can be found out, by the way, I think. So this is also L by 2. Let's give it a try. So I can say the height, or I can simply say if these are theta, then what I will realize is that this is L by 2 sine theta. This is also L by 2 sine theta. So if I take this as the origin, taking O as the origin, the coordinate, x coordinate would have been minus L by 2 cos theta, right? So taking O as origin, x coordinate for A would have been minus L by 2 cos of theta. And how about the y coordinate? Y coordinate of A would have been this entire height, which would have been L cos theta, L by 2 cos theta, and L by 2 cos theta. So L cos theta. Okay. So what you'll realize is that you can relate these. You can relate these. You can say that y equals if I just divide these two. I just divide these two. What am I getting? Would be changing at all times. Okay, so let's see if we divide xa over ya to be equal to minus 1 by 2. This is the equation that I'm getting. Okay, definitely not a parabola. Hello ARJ, how are you? Okay. So again, this also would have been solved by using the fact that the trajectory, the trajectory of the CM falls in a straight line, then apply energy conservation to find the omega at any theta, and then find the other answers. Okay. Again, you have another problem. This also you will realize is a pure rolling standard question. Okay, this also you would have done it. And then you have another problem which was asked in JEE. Again, a thin uniform rod held vertically. So rods falling on floors seem to be important to JEE people. They like questions on that. So practice some of those. Okay. Now this is a problem which I wanted to tell you immediately, that for toppling, you realize all you had to do was make this MP go like this. Okay. And then you would have solved this also. So practice these problems. If you have any issue with any of the questions, then you can let me know in the next class. Okay, today our time is up, so I'd like to wrap up today's session. Now, before I go, let me remind you that you can get your Unacademy Plus subscriptions if you haven't gotten them already, and this is how you do it. Go to the Plus section of the app, select your goal as IIT JEE, and click on the Get Subscription button. Now, when you redirect it to the payment page, do not forget to use RD Live code, and now you can pick from the Plus subscription or the Iconic subscription. The Iconic subscription will take your JEE preparation to the next level. This will help you plan for JEE better. You will be allotted personal coaches. You will be able to attend a lot of IIT workshops, expert guidelines, study planner, and test analysis sessions. Now, furthermore, the Unacademy JEE Combat is going to be happening. The next event is going to be happening on 20th of December. You can enroll in that with the code RDLive, compete, do well, and win a lot of money and prizes. If you like today's video, then don't forget to press the like button and share it with as many people as possible. Don't forget to subscribe if you're new to the channel. Also press the bell icon to keep receiving notifications of all the lectures happening here, and the PDF notes of all these slides used in today's lecture will be available for download very, very soon. Those following us on the JEE English channel of Telegram app should be connected with us on the Telegram using this link. And before I leave you one last time, this is my code RDLive. Use this to get your subscription and enjoy a 10% off. So I'll see you next week. Till then, you guys keep practicing, keep working hard, and